Ever wondered how your digital camera turns light into a digital image? It's a fascinating process that involves the interplay of light, physics, and technology. Imagine a scene, a beautiful sunset perhaps, that you want to capture with your camera. The light from that scene, which is electromagnetic radiation, contains countless tiny particles called photons. These photons, carrying the colors and brightness of your sunset, strike the surface of the image sensor in your camera. This image sensor is usually made of a silicon semiconductor material, which has the unique property of being able to absorb these photons. Once the photons hit the sensor, they're not just absorbed willy-nilly. The energy they carry is used to excite electrons in the semiconductor material. This creates what are known as electron-hole pairs. The material of the sensor is often doped or treated to create regions that attract positive charge carriers or holes and regions that attract negative charge carriers or electrons. Due to the internal electric field within the semiconductor, the generated electrons and holes start moving towards their respective regions. The electrons head towards the negative region and the holes towards the positive region. Now, here's where it gets interesting. The image sensor in your camera has a structure with potential wells that can trap and hold these photo-generated electrons. These potential wells form a pattern that corresponds to the spatial distribution of the incident light. Basically, they're creating a map of the light from your sunset. The accumulated charge in these potential wells is then sequentially transferred along the rows and columns of the sensor array. This transfer is done by manipulating the voltages applied to the electrodes within the sensor structure. To maintain signal integrity and prevent degradation over distance, the charge packets may be amplified as they are transferred through the sensor array. These amplified charge packets, now representing the intensity of the light at different locations on the image sensor, are then converted into analog voltage signals. These analog signals are then further converted into digital numbers by an analog-to-digital converter, ADC. This process assigns a digital value to each voltage level, creating a digital representation of the captured light intensity. Finally, the resulting digital numbers are processed and assembled to form a digital image. This digital image can be stored, displayed, or further processed using various image processing techniques. And there you have it, a digital image created from electromagnetic radiation. The photons from your sunset have been captured, converted into an electrical charge, transferred, amplified, and transformed into a digital image that you can share, print, or simply enjoy. To sum up, the creation of a digital image involves the absorption of photons by an image sensor, the generation of electron-hole pairs, the movement of these particles to their respective regions, their collection in a potential well, the transfer and amplification of their charge, and finally, their conversion into a digital image. From the beauty of a sunset to the complex workings of your camera, it's an incredible journey of light into digital data.